So good afternoon students. So welcome to rapid revision series. Today we are going to discuss that is one shot number 8 and our chapter is electrostatics. So hope all are here very well and you are solving very good number of questions. You are doing great revision. So this time to do for mostly revision part. No need to study any other extra things. You just go for revision part and solve as much as questions as much as possible. So that is only that will help you in this time. So as the time progresses, there might be cases like you might be feeling only this much days is left, something like that. So whatever the notes that you have made already, those notes go and revise, and also you solve some previous year questions, whatever as much as possible. So today that we are going to discuss electrostatics. So we can divide this electrostatics by two chapters. One is electric charge and field, and second is electrostatic potential and capacitance. So we can divide the chapters in this particular four subtopics: electric force, electric field due to the charge distribution, electric flux and Gauss law calculation. Next we have electric potential and electrostatic potential energy, and last part is the capacitance. If we talk about this electrostatics over the 5 years, if we see the number of the questions they are asking, that is we are getting 3 questions, 2 questions. So on an average 3 questions from this, including the capacitance as well as electric charge and field, the questions are asked, that is 3 questions per year. Now so let's start today's journey without wasting any time over here. The first one that we are going to discuss, what is electric force, what is electric field, and electric field due to charge and charge distribution. The first one is that very basic form, that is Coulomb's law, that is if two charges q1 and q2, they are separated by some distance r, then force is given by k q1 q2 divided by r square, where k is nothing but 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9, 10 to the power 9, k q1 q2 divided by r square. So this is the force between two charges. If both the charges are positive, like charges, they will repel each other. If one of them is positive, other is negative, then they will attract each other. So this happens during when the charges are in air. So if the charges are in medium, we can write here 1 by 4 pi epsilon naught into er into q1 q2 divided by r square. So this particular formula we use when the charges are kept inside a medium, and that medium is having relative permittivity value er, and this er we also call it as relative permittivity, and there's one more name that is given, that is k. What is k here? Dielectric constant. For example, if two charges are in air, exert the force of 80 Newton on each other, the same charges when placed in water at the same distance, they will exert a force of 80 by 80, that is 1 Newton force they will exert. So forces will reduce by how many times? 80 times. So what is 80 here? 80 will be the dielectric constant of the water. So dielectric constant of the water is 80. So this is the forces in medium. If you have multiple charges like this, suppose if you have q1 and here we have q2 and third charge is q3, the forces between charges q1 and q2 will not depend on q3, will not be affected by q3. The forces between q2 and q3 will not be affected because of q1, and the forces between q1 and q3 will not be affected because of q2. So forces between any two charges is independent of the third charge present. So this is what we define principle of superposition also. And what is the force that is acting? If consider all of the positive over here, this side I will writing this F31, and this will be F13, this will be F12, and this will be F32, and this will be F32. So whatever the forces that is acting between q1 and q2 will not be depend on this third charge over here. And if they're asking what is the net force acting on the charge 1, I will writing this, that is nothing but F12 plus F13. This is the net force that is acting on charge 13. Vector sum we have to do. Vector sum along with the angle, it will depend on that. So these things that we should keep in mind. Next we define that is electric field. So what is electric field? Electric field is defined as force. Electric field is defined as force acting on the charge divided by charge itself. So force divided by charge is what we define electric field. This one is vector quantity again. We have so many terms over here. Electric field is vector quantity, that is force divided by charge itself. So electric field due to point charge, if we talk about this, electric field due to point charge, due to positive point charge. So this will be writing this, due to point charge, electric field is given by k q divided by r square, and this will be q, and this particular point distance, this particular point we want to calculate, so this will be k q divided by r square. If it is point charge, if it is negative charge, E is equals to minus kq divided by r square. So magnitude will be same, but it is negative charge. Direction will be changed, because of that we are writing this minus If it is positive charge, it will be away from the charge like this. If it is negative charge, it will be towards the charge like this. So this is the electric field due to the point charges, point charge kq by r square. What is k value again? 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9. So if we talk about this electric field due to continuous charge distribution, electric field due to multiple charges. If you have not only single charge, if you have multiple charges like this, so for that, if you charge q1, second charge is q2, and third charge is q3. And this particular point you want to calculate electric fields. Because of this electric field is this direction, that is E1. Because of this electric field is that is away from the charges, and because of this electric field, that is E3. So electric field at point P is given by EP is equals to E1 plus E2 plus E3. So net electric field at point P is given by sum of all the electric field acting at that particular point because of all the charges. So this is the net electric field. Again, this is the vector sum. This is not a scalar sum. This will be vector sum over here. Electric field due to multiple charges. If we have continuous charge distribution that we are going to discuss for the ring, for the rod, okay, for the spheres that we are going to discuss. So first one, that is for the ring. Electric field due to ring. And due to ring, what is electric field? Suppose if this one is the charge is distributed over the circumference of the ring, and we want to calculate electric field because of this. So at a distance, it will increase like this, and again this side it will decrease like this. So this particular point from the center, if we take this particular point from the center, that distance is r by root 2, and these are also distances minus r by root 2, provided that r is the radius of the ring. So at that particular point, r by root 2 or minus r by root 2, electric field because of the ring will be maximum. And what is the value of this electric field due to ring? The value of the electric field due to ring is given by E k capital Q x divided by r square plus x square to the power 3 by 2. So k capital Q x divided by r square plus x to the power 3 by 2. This is the electric field due to ring. K q x divided by r square plus x square to the power 3 by 2. Again, if you talk about exactly the center, putting the x value exactly the center, x is, if this is the ring, x will be distance from the center of the ring. So at the center, if we talk about the center, x value is 0. If x value is 0 means what is electric field value? That is also 0. Electric field value is also 0. So this is the what we are getting electric field due to the ring, kqx divided by r square plus x square to the power 3 by 2. Next we have electric field due to rod. Electric field due to rod on an Excel line I will write this. Electric field due to rod. So this, if you have the rod like this, and this is the positive charges, and at this particular point if they are asking electric field value, so this distance is r, and this will be how much? L. So this total distance is r plus L. So electric field at this particular point on Excel line of the rod will be writing this K, that is Q, that is a total charge on this, divided by R into R plus L. That's it. And direction of this will be always away from the positive charge. If they're asking electric field because of the positive, it will be always away from this. If they're asking electric field due to negative charge, will be towards this. So this will be KQ divided by R into R plus L. This is electric field at point P that we calculate because of the rod. Remember this formula, note down this formula, direct formula. Sometimes we write Q in terms of the lambda into L. So what is lambda? Lambda is linear charge density, charge per unit length, linear charge density. Lambda is equals to Q by L also, right? Next we have electric field due to ring is done. Due to rod, if we have like this particular, it is going to infinite rod. So electric field due to infinite rod, if you write this, electric field due to infinite rod. So if the rod is infinite and rod is giving charge, and what is charge rod is given, that is lambda charge is given. So at this particular point, distance r from the rod, we are calculating electric field value, and what is electric value? 2k lambda divided by r. So this is a direct formula. Again, we don't have time for the derivation, right? So this will be E is equals to 2k lambda by r, where lambda is the linear charge density on the rod. Lambda is linear charge density on the rod, and this we can write in terms of the small r. So 2k lambda divided by r. Next we have spheres. So in spheres we have two types of spheres. Spheres we have two types that we are going to discuss. First one is hollow sphere. So let's discuss for the hollow sphere, then we'll go for the solid sphere. So if this one is the hollow sphere, at this particular point, if you want to calculate electric field, that is inside any point, and second point outside, and third point, the second point on the surface, and third point outside. So this hollow sphere, we also call it as conducting solid sphere. So hollow sphere or conducting solid sphere means charge will become on the surface, or conducting solid sphere or hollow sphere, a spherical shell also they have mentioned. In that case, we'll be writing this 0.1, 0.2, 0.3. Electric field at 0.1, that is inside at any point electric field value will be 0, because all the charges are there on the surface. All the charges will be there on the surface. Electric field inside will be 0. Electric field on the surface will be given by, this is kq divided by capital R square, where capital R is the radius of the spherical shell, and third particular point, that is kq divided by small r square. And what is small r? Distance from the center of the point about which we are calculating the electric field. So this is the outside point, electric field point, that is outside, kq divided by r square. And this one is inside, electric field value will be 0 on the surface, kq by r square, and this is the outside point. So if you draw the graph of this, the graph of this will be like this. So this particular point, that is r equals to 0, and this one is electric field, and this one is small r. So for this range, electric field value will be 0, and after that electric field will decrease like this, 1 by r square. Sometime this particular questions we can solve using this q is nothing but in terms of the sigma. What is sigma? Surface charge density. So sigma multiplied by A. And what is area of this sphere? So q is equals to sigma multiplied by area of this sphere, 4 pi r square. We'll be solving this using, depending on the questions, we'll be using this as well. Next we discuss for the hollow sphere or conducting solid sphere. Let's discuss non-conducting electric field due to non-conducting solid sphere. So we'll discuss this, what is non-conducting solid sphere. So what is conducting? If we give any charge on this, the charge will come on the surface. So that will be conducting solid sphere. If it is non-conducting, if I am giving any charge like this, charge will remain throughout its volume. So that will be non-conducting solid sphere. So if we talk about this particular point, 1 inside point, 2 surface point, and 3 point is outside. So the distance, this will be r, this will be capital R, and this will be, we'll be writing this again, this will be small r. Electric field inside at any point, this is given by kq divided by 2r cube into 3r square minus small r square. At any point inside, when r is less than capital R, electric field value is given by this particular expression. Electric field on the surface, the electric field on the surface, sorry, this is for electric potential, this one will be writing this k capital Q into small r divided by r cube. Electric field on the surface is given by k q divided by r square, and electric field outside the surface will be writing this, that is k q divided by r square. So this k q by r, so this electric field is proportional inside, and this will be electric field is inversely proportional to r square outside. If you talk about the graph, it will be like this side E and this side small r. Okay, so these are the electric field as we have in case of electric field calculation. So let's see some of the questions, some of the good questions, that previous year questions that I have taken for you. The 2-point charges A and B having charge plus Q and second charge minus Q respectively are placed at certain distance apart, and force between them is F. What is force right now? That is K into Q into minus Q divided by distance is R square. Now if 25% of charge A is transferred, so 25% of Q is transferred to B, so how much is remaining here? So this side Q minus Q by 4, and how much we got here? Minus Q plus Q by 4. So this will be, this is 3Q by 4, and this also 3Q by 4. So what is the total charge here? So distance remains same, so this will be writing this. So what is the force? New force K into 3Q by 4 into again 3Q by 4 divided by distance. Distance is R square, so this will be 9 by 16 KQ divided by R square. So this particular term is F only, so this particular term, that is F dash, is 9 by 16 F. Answer is option C. Clear? Answer is option C. Moving next particular question over here. A charge Q is placed in the center of the line joining the two equal charges. So here we have charge Q, here we have charge Q, and we are keeping one more charge at the center. Whatever the magnitude of the charge that we are keeping at the center, that center charge will always be in equilibrium. But remember, suppose if you want the system to be in equilibrium, this one, and whatever the charge, if I am keeping this would also be in equilibrium. In that case, this Q value is directly minus Q by 4. So in this case, this three will be in equilibrium. In other case, whatever the charge you are keeping, that will be in equilibrium. So in this case, Q equals minus Q by 4, what will happen? This all three charges are in equilibrium. So this, if I am keeping this Q, if I am keeping this Q, if I am keeping this Q, then this will also be in equilibrium, but not these two charges. If random Q I am taking, not these two charges. But if I am keeping Q is equals to minus Q by 4, then this charge as well as this charge will be in equilibrium. I hope this is clear to everyone. Wait. So here we have two charges, Q and this Q. This is minus Q by 4. So we are getting this. This is correct. Anish Pandey, this one is correct. Answer is option C only. I don't know which one you're saying it wrong. So moving next question now. Two parallel infinite line charges with linear charge density lambda and minus lambda are placed a distance of 2 are in free space. What is electric field midway between the two charges? So right now, this one is positive lambda. Electric field because of this, and electric field because of this, that we have to calculate. Because of this electric field, suppose if I calculate this, electric field will move away from this. So this side, 2k lambda divided by what is distance? What is distance? The distance is 2r. So whatever this distance, this will be r, and this will also be r. So this electric field because of this will be writing this 2k lambda divided by r. Next we have, so if we talk about this, this is 2k lambda by r, and because of this also, so because of this also that we want to calculate electric field, that is also in the same direction 2k lambda by r, because this is negative charge, and add the magnitude because you already considered the direction. So what is net electric field? The net electric field is given by 2k lambda by r plus 2k lambda divided by r, 4k lambda divided by r, putting the value of k is equals to 1 by 4 pi epsilon naught. So this side 4 into 1 by 4 pi epsilon naught into lambda divided by r. 4 cancel, lambda divided by pi epsilon naught into r is the correct option over here. Moving next, that is electric flux and Gauss law. So what is electric flux? The flux is defined as electric field dot area. So if electric field exists in this particular manner, and there is one area vector, and that area vector is this one. So electric field, this particular angle is theta. So flux passing through this, flux is proportional number of field lines passing through given area vectors. So this we can write here, phi is equals to E A cos theta, where theta is the angle between area vector and electric field. If electric value is not constant, we'll be writing this integration of E dot ds is equals to flux. If electric field is not constant, we'll be using this. Electric field is constant, we'll be using this particular value. If the theta is 0, right now, in this particular case, theta is 90 degree, the flux will be 0, area vector is coming outward. In this case, flux will be 0. And flux here, E, A, cos 90. So in this case, flux is 0 because 90 is 0. If we talk about this one, electric field, what is area vector? Area vector in the same direction, electric field in the same direction. So phi is equals to E into A. This electric field. Incoming flux is taken as negative and outgoing flux is taken as positive. Remember this particular line. Incoming flux negative, outgoing flux positive. Gauss law talks about that. Suppose any charge distribution, surrounding any charge distribution, we have to consider one hypothetical or real Gaussian surface. That Gaussian surface should be hypothetical, should be closed in the surface. It should be closed. The Gaussian surface should be closed. And what is the flux that is passing through this Gaussian surface? So if we talk about this, the total flux passing through this Gaussian surface is given by Q enclosed divided by epsilon naught, and this is integration of E dot ds. What is electric field? Electric field is the electric field due to E is the electric field due to charges which is present inside as well as outside. But this depends on only. So this depends on only what? So this flux depends only on inside charges. This depends only on inside charges. But what are this electric field? This will depend. Electric field is due to inside as well as outside. Remember this, inside as well as outside. And flux will not depend on size of the Gaussian surface. Flux will not depend on, flux does not change if you change the size of the Gaussian surface, if you decrease the size of the Gaussian surface, and if you increase the size of the Gaussian surface, then it has certain application. What is application? Those things that we discussed, Gauss law application that we discussed, electric field calculation we have to do. What we have to do in this case, integration of E dot ds is equals to, this is the flux, okay? And what is flux? Flux also we can calculate from here. If electric field is constant, integration of ds is equals to phi. And phi we can calculate from here, that is how much charge enclosed, q enclosed by epsilon naught. If the charge is single positive charge, the Gaussian surface that we consider is spherical in shape. Remember this, spherical Gaussian surface, okay? If the charge is linear charge, like the charge is distributed over the length, in that case the Gaussian surface is distributed over the Gaussian surface will be cylindrical in shape if the charge is distributed over this. Suppose if the charge is again spherical, for this again Gaussian surface will also be in spherical shape, and just now we got electric field inside will be 0 on the surface kq by r square, outside the surface kq by small r square. This will be the Gaussian surface over here. Next we have, if we have this plane sheet of the charge, plane sheet of the charge, two types of charge will be there, plane sheet of the charge. One is infinite thin sheet charge, and second is thick sheet. So this, in this case, electric field because of near to this is sigma by 2 epsilon naught this way, and this side also sigma by 2 epsilon naught because of this electric field. If it is conducting little bit thicker is there, if it is conducting thin sheet is there, and they are asking electric field value. So this side sigma by epsilon naught, and this are also sigma by epsilon naught. Conducting has two sheets over here. Conducting sheet sigma by epsilon naught. So let's solve some of the questions from the Gauss law and electric field further. According to the Gauss law of electrostatics, the electric flux through a closed surface depends on area of the surface. No. The quantity of charge enclosed by surface, yes. The shape of the surface, no. The volume of the enclosed by the surface, no. It will not depend on volume, it depends only on the charges which is inside it. And it will not depend on the radius, it will not depend on the size as well. Integration of E dot ds is 0, means flux is equal to integration of E dot ds is 0. 0 means q enclosed divided by epsilon naught. Flux is also 0. The magnitude of the electric field on the surface is constant. I can't say about this. I can't say electric field may be constant, may not be constant. Next, all the charges must necessarily be inside the surface. No, the electric field inside the surface is necessarily uniform. The number of flux lines entering the surface must be equal to number of flux lines leaving it. The flux line which is entering the surface will give us negative flux, and the flux line which is coming out of the surface will give us positive flux. So net incoming flux should be equal to net outgoing flux. Is that clear, all of you? Net incoming flux should be equal to net outgoing flux. So flux value will be 0. Flux value will be 0. Answer is option D. Next question over here. A hollow cylinder has a charge q coulomb within it. If the phi is electric flux in units of voltmeter per second with the curved surface. So this curved surface they are asking. So in this case, what is the flux through this is phi. The flux link within the plane surface A is unit of voltmeter. So there is one charge that is kept, has a charge q coulomb with it. There is one charge that is kept over here. Because of this charge, if we calculate the flux on this curved surface is phi, and we want to calculate what is the flux that is passing through this surface and what is flux that is passing through coming out from this surface. So if we talk about the flux, total flux which is coming out, how many surfaces it has? One is curved surface, second is this plane surface, and third is this also plane surface. In that case, flux through A plus flux through B plus flux through C. Now because of the symmetry, whatever the flux which is passing through C, the same flux will be passing through A also. So flux through A plus flux will be, I can write it 2 times of flux through A plus phi B is equals to Q phi total. What is phi total? Q by epsilon naught. This will be Q enclosed divided by epsilon naught. So Q by epsilon naught minus this is given phi is equals to 2 times of phi A. So what is phi through A? So that we can write here, Q by epsilon naught minus phi divided by 1 by 2. Is that clear? Answer is option D. Answer is option D. Very good. Next we have a charge q is placed at the center of the cube. The flux coming out from any one of its space will be the flux which is coming out from its space. So right now charge q is placed at the center of the cube. Okay. So if the charge is placed at the center of the cube and they're asking So imagine if the charge is placed at the center of the cube. So flux through entire cube, you can note down this, flux through entire cube, flux through entire cube is how much? Q by epsilon naught. Flux, how many phases it will be having? 6 phases. So flux through one phase will be given by how many phases? 6 phases. So total 6 phases, Q by epsilon naught. Like that, how many phases? 6 phases are there. So one phase, how much? 1 by 6 multiplied by flux through entire this. So this will be Q by 6 epsilon naught, right? So answer will be Q by 6 epsilon naught. Okay, fine. So Q microcoulomb is placed. So in this particular case, Q by 6 epsilon naught. Next we have coming out from any one of these phase in SI unit. Next we have, if we talk about this, if second cases, so this particular answer will be here, Q by 6 epsilon naught into 10 to the power minus 6. Now, suppose if the question is asking if I am keeping the charge at the corner and what is the flux through cube. So in this case, if I am keeping the charge at the corner, charge is at corner and flux is at cube. Charge is at corner, and if they are asking flux, so what is flux? Q by 8 epsilon naught. If the charge is at corner, Q by 8 epsilon naught. If the charge is at face center, this is flux through entire cube, and flux through adjacent face will be 0. Flux through adjacent face, what is adjacent face? Where the charge is touching this. So this one, and this one, the back one, it will be 0. It will be 0. The flux through non-adjacent face. Flux through non-adjacent face means the where the charge is not touching that face. In that case, it will be non-adjacent face. In that case, I will be writing this flux equals to Q by 24 epsilon naught. How we are getting this? This is through complete cube, and they're asking for one phase. How many non-adjacent phase we have? 3 non-adjacent phase we have. So divide by 3, that is Q by 24 epsilon naught. When the charge is placed at the corner, okay? When the charge is placed at the corner, if the charge is placed at the face center, so like this, if the charge is placed at the face center, in that case, they're asking what is flux to the cube. Flux to the cube in this case, that is Q by 2 epsilon naught if the charge is placed at the face center. So moving next question over here. The question is, a hollow metal sphere of radius r is uniformly charged. The electric field due to the sphere at a distance r from the center. So if this is the hollow sphere of metal of radius r, the electric field due to the sphere at distance, how much distance? R distance. So if it is r is less than capital R, what is this hollow metal sphere? What is electric field? 0. Okay. R is less than capital R, it will be 0. So 0 as R increases for R is less than capital R, and after that, if I take this particular point, so this particular point when the R is greater than capital R, outside point, and what is outside point electric field? Just now we saw that is KQ divided by R square. So this E is equals to 1 by R square. E is equals to 1 by R square. In this case, what we are getting this? It should decrease with this, right? As the R increases, electric field should decrease. Which option is there? 0 as increases R for less than R, decreases as R increases for R greater than capital R. Option A. Option A. Okay. So E is inversely proportional to R square. It should decrease with it. Decreases as R increases for R greater than capital R. It should decrease. Again, a spherical conductor of radius 10 cm has a charge of 3.10 to the power minus 7 distributed uniformly. What is the magnitude of the electric field at a point 15 cm from the center of the sphere? So at this particular, if the charges are distributed, spherical conductor. Conductor means inside electric field will be 0. Remember this. Electric field inside will be 0. But they're not asking inside electric field, they're asking the outside point. Because radius is how much? The radius is 10 cm. We have to find at this particular point, that particular point distance from here is, that is 15 cm. So what is electric field value? E is equals to K capital Q divided by R square. E is equals to K value 9 into 10 to the power 9. And what is the charge? The charge is given by, that is 3.2 into 10 to the power minus 7 divided by distance. What is distance? 0.15 ka square. So this is 2.25, and this divided by 4. 3.2 into 4, we are getting 1.28. All the options are here 1.28. So this side 9 into 10 to the power 9 into 3.2 into 10 to the power minus 7 divided by 2.25 into 10 to the power minus 1. Minus 2 we are getting. 10 to the power minus 2. So this one is 1. This will be 4. 3.2 into 4. 3.2 into 4, that is 12.8 into 10 to the power 9 minus 7 plus 2 minus, this is plus 4 we are getting. So 1.2, 12.8 10 to the power 1.28 into 10 to the power 5 into 10 to the power 5 Newton per coulomb. Okay. Then here we define, that is the second case, second part of the chapter, that is the second chapter, electric potential energy and potential energy. So if you have two charges Q1 and here charges is Q2, the distances are, then U is given by K Q1 Q2 divided by R square. Sorry, K Q1 Q2 divided by R. That is the electric potential energy, K Q1 Q2 divided by R. So U is equals to K Q1 Q2 divided by R. Okay. So here potential energy between two charges K Q1 Q2 by R. If both the charges are positive, potential energy will be positive. If both the charges are negative, again potential energy will be positive. If one of them is positive, second is negative, then potential will be negative, and vice versa also. So in this case, what will happen? Potential energy is positive, U is positive. When both the charges is positive, if U is positive means forces are repulsive. If U is negative means forces are attractive. So this is potential energy, and here we define work done. Certain formula is there. Work done is given by delta U, that is change in potential energy. Okay. So work done by external agent. So this is by external agent. And if they're asking work done by electric field, so this will be minus of delta U. So this will be minus of delta U. What is delta U? Change in potential energy. Now here we define electric potential. Electric potential is numerically defined as electric potential energy per unit charge. So potential energy divided by charge itself. So if you have two charges Q1 and Q2, distance between them is R, then electric potential it is given by, that is K Q1 Q2 divided by R divided by Q1 if we are finding at point P, it is, and if we are finding at point Q, this will be K Q1 Q2 divided by R divided by distance divided by charge Q2. So this will be K Q2 divided by R, and this is K Q1 by R. So if we have point charge, one single charge is there at this particular point, if they are asking electric field value, so electric field value is given by K, electric potential value is given by K Q by R because of the point charge. If it is negative, if it is just negative at this particular point, if you want to calculate, so electric field value is given by K Q divided by small r. Again this will be minus. Again the potential is scalar quantity, so no need to worry about the direction when you are solving from the problems from the electric potential. No need to worry about direction. If you have multiple charges, so if you have multiple charges Q1, second is Q2, and third is Q3 over here, and at this particular point we want to calculate the electric potential. Multiple charges, so this one is R, this one is R, this one is R. So electric potential at point P is given by, that is K Q1 by R plus K Q2 by R plus K Q3 by R. If distance are R1, R2 and R3, so this will be R1, R2 and R3. So like that, this we have to add it just like a scalar, just like we add the numbers 3 plus 2 is equals to 5. Like that we will be adding this electric potential. So let's see some of the questions from this electric potential energy. So electric potential energy, two charges Q1 and Q2. So here charges Q1 and here charges Q2. They are separated by a distance of how much? 30 centimeter apart as shown in the figure. A third charge Q3 is moved, and third charge Q3 I will making over here. If it is not clear, Anish Pandey, if it is not clear, I will try to make it clear. Charge is scalar hai, charge is scalar hai. Anish Pandey, charge is scalar quantity. Charge is not a vector quantity. So this one is Q1, and this side here we have, this one is Q3. So this Q1 and this will be Q2, and distance between these two is how much? 30 centimeter. And this we have to bring this particular position. Now what they are asking? Two charges Q1 and Q2. This distance that we already know, that is how much? 40 centimeter. Are placed 30 centimeter apart as shown in the figure. The charge Q3 is moved along the circle of arc how much? 40 centimeter. The change in potential energy of the system they are asking. Now I will tell you one thing over here. The change in potential energy of Q1 and Q2 is not changing, because distance is how much, and what is formula? The formula is given by K Q1 Q2 divided by R. So U is equals to K Q1 Q2 divided by R. This is the formula that we are having. So this potential energy between these two charges is not changing. Between these two charges should change or not, we have to check it. What is distance right now? 40 centimeter. When it is comes over here, what is distance right now? Again 40 centimeter. So between these two charges is also not changing. So what is change happening? The change is happening for these two charges. So what is initial potential energy? K Q1 K Q2 Q3 divided by distance. What is distance? This one is 40, this one is 30, so this will be how much? 50 centimeter. This will be 50 centimeter, this will be 0.5 meter. Okay, 0.5 meter. Next, for this particular orientation, what is u2? Again, k q2 and k q2 and q3 divided by distance. What is distance? This is 0.1 meter. So this one is u1 and this one is u2. What is the change? You have to calculate. That's it. So this side, delta u final minus initial u2, that is u2 minus u1. So this, if I take this k q2 q3 common, so 1 by 0.1 minus 1 by 0.5. That's it. So this, how much we are getting? So solving this particular case, we'll be writing this k q2 q3 divided by, so this one is 10 and this one is 2. 10 minus 2, how much? 8. So we are getting 8 into 1 by 4 pi epsilon naught q2 q3. This is delta u, right? So let's check this. What is the answer over here? So let's check this. What is the answer over here? Delta u is equals to 8 by 4 pi epsilon naught q2 into q3. So this side, what is the answer? q3 4 by epsilon naught. So this q3 4 pi epsilon naught. So bacha kya? 8 q2 will be the answer. So this particular value is q3 4 pi epsilon naught. So this k value is 8 q2. Next we have the value of the electric potential. The value of the electric potential at distance of 9 cm from the point charge is this one. What they're asking? Value of electric potential. Simple question is there. Q is given at this particular point. They're asking what is value of electric potential. So what is value of electric potential that we are calculating? So Vp is equals to, I will be writing this kq by r. Okay. Put the values. Put the values. Vp 9 into 10 ki power 9 into q value. What is charge? 4 into 10 ki power minus 7 divided by distance. What is distance? Distance is 9 centimeter. So 0.09. So this one is 1 and this one is 100. So we are getting this 4 into 10 ki power 2, I guess, right? 4 into 10 ki power 2. Yes or no? So this 400 10 ki power 2, 400 into this side 10 ki power 2. So value of the electric potential will be answer option D. That is 4 into 10 ki power 2. Next we have this 4 electric charges plus q minus q are placed at corners of a square of side length 12. The electric potential at point A midway between the two charges plus q and plus q is given by, between the plus q and plus q. This particular point, so this one is plus q, this one is also plus q, this one is minus q and this one is also minus q. They are asking what is electric potential at point A over here. So electric potential at point A will depend on all the charges. Whatever this distance now, this will be L by 2. Okay, because total is L. Whatever this is now, this will be L by 2. Whatever this one, so this one is L by 2 and this one is how much? L. So this will be under root, this will be under root L square plus L by 2 whole square. And whatever this one now, this will be under root, this is L by 2 and this one is how much? L. Using the Pythagoras theorem we can calculate, this one is L by 2, this also, this will be under root L square plus L by 2 ka whole square. Now they are asking electric potential at this particular point A. Because of this charge, I will be writing this k q divided by how much distance? L by 2. Because of this charge again, plus k q divided by L by 2. Because of this minus q charge, distance now we calculated. So this I will be writing minus k q divided by L square plus L square by 4. How much? L square plus 5L square by 4. So this side L by 2 under root 5L square by 4. Okay. Multiply by 2 kar do. I will 2 because this is also the same thing. So this I am getting, this will go this side 4kq by L, 4kq by L minus 2kq divided by under root 5L square by 4. Okay, under root 5L square by 4. So you can check this one is plus 5, this one is also plus 5, only this answer is there, that is having minus 1. Clear? So we can solve it because this one is minus, this also we are getting minus. सेकेंड केस में डिस्टेंस कैसे लिए? कौन सा डिस्टेंस? ये वाला डिस्टेंस हो गया L by 2, ये वाला डिस्टेंस कितना हो गया L, और ये वाला डिस्टेंस कितना हो गया L by 2. तो ये L by 2 और ये L, तो ये कितना हो जाएगा पाइथागोरस थ्योरम से? L स्क्वायर प्लस L स्क्वायर बाई 4. यही क्वेश्चन. अगर तुम इस क्वेश्चन से पूछ रहे हो, इफ यू आर आस्किंग फॉर दिस, व्हाट इज डिस्टेंस हियर? 50 सेंटीमीटर. This will come this side, so this will be how much? This one is 50 centimeter and this one is 40 centimeter. So this will also be 40 centimeter. Remaining how much? This one is 30. So this will be 10 centimeter. Yeah. The electric field distance theta by 2 from the center of the charge conducting spherical shell of radius is E. The electric field distance r by 2 from the center of the sphere is 0. So it is nothing but answer is 0. That's it. Why? Because electric field distance, whatever the distance they mention, center of what? Charge conducting a spherical shell. So from this distance, how much distance they're asking? So this particular distance is 3r by 2. So this particular distance value, electric field value is E. And they're asking at the distance, how much distance? From this particular point, how much distance they're asking? Distance is r by 2. Second, in the second case, electric field distance, how much? R by 2 from the center of the cell. So this distance, that is r by 2. This one is inside only. So what is the electric field inside? It will be 0. Okay, electric field inside will be 0. A thin spherical shell is charged by some source. The potential difference between the 2 points C and P is given by. Okay, right. So this is potential difference between point C and point P. Thin spherical shell. Again, spherical shell they have mentioned. What is electric field inside the shell? The electric field inside the shell is 0. Right? And okay, electric field is 0. What about electric potential? Electric potential, we know that. What is electric potential? K capital Q divided by R. So if it is spherical shell at point 1, inside point 1, K Q divided by R. This side V2 is equal to K Q divided by R on the surface, and outside the surface distance from the center, electric potential is given by KQ by small r. Okay, so KQ by R inside, KQ by R on the surface, but on the outside is equal to KQ by small r. So this V is equal to KQ by R at the center. Okay, next between the 2 points C and P, P is where? Again P is also KQ by R because P is also on the surface. P is also on the surface and C is inside, that is also KQ by R. So potential at point P and potential at point C is same. So what is potential difference? Answer is option D. Clear? If a conducting sphere of radius r is charged, then electric field distance r is greater than r from the center of the sphere would be given by. So again the question from electric field and electric potential. So this electric field distance r, that r is greater than capital R from the center of the charge would be given by. Okay, fine. So V is the potential on the surface of the sphere. What is V on the surface of the sphere? That is K Q by R. You do one thing, you calculate Q from here. What is Q? R V divided by small k. That's it. The potential role is gone now. Now we have to find electric field distance how much? Small r. So this is small r. That small r is less than capital R. So that this particular point, if you want to calculate electric field, what is formula? KQ R. This one is what? Conducting, no? So this will be KQ. Electric field value will be the electric, if the conducting spherical, the electric field distance R is greater than capital R. Sorry. This question is asking R is greater than capital R. So in this case, if we have this distance is R, this particular point P, we want to calculate electric field. When R is greater than capital R, what is electric field value? KQ by small r square. I told you what is Q value from here. चिपका दो यहाँ पे, ये वाला वैल्यू यहाँ पे चिपका दो. We are getting this E is equal to K by R square into R V by K. K और K cancel. How much you got? R V by R square. Answer is option C. Okay, answer is option C. Two charged spherical conductors of radius R1 and R2 are connected by a wire. Then the ratio of the surface charge density of the sphere. So they are connected by a. The two charge pairs are connected by a wire. So this one is, let's say, the first one is having radius R1 and second one is having radius R2. Okay, first one is having radius R1, second is radius R2. So remember this, whenever two charge pairs are connected, so then they will be having same potential value. Remember this line, they will be having same potential value. So this particular point V1 and this is V2. So what is V1? K Q1 divided by R1, and what is V2? K Q2 divided by R2. But we don't want in terms of the Q1 and Q2, we want in terms of the sigma. What is sigma? So what is Q1? Sigma into 4 pi R1 square, and what is Q2? The Q2 value will be given by sigma into 4 pi R2 square. Putting these values over here, we'll be writing the K value is 1 by 4 pi epsilon naught into Q1. What is Q1? Sigma 4 pi R1 square divided by what is the distance? Again this will be R1 is equal to this side, sigma into 4 pi R2 square divided by 4 pi epsilon naught into R2. So this side 4 pi, 4 pi, 1 R1 cancel, 4 pi, R2 cancel. So what we got here, sigma 1, and this one is sigma 2. So this one, sigma 1 into R1 by epsilon naught is equal to sigma 2 into R2 by epsilon naught. Both are having same potential. So this will be answer is option, which option? Sigma 1 by sigma 2, R1 by R2. Clear? So this will R1 by R2. Right. So this will be R1 by R2 because sigma 1 by sigma 2 will be calculating from here. Sigma 1 by sigma 2. Right. So combination of drops. This particular questions we have solved using, in the class I told you direct formula. What is that formula? Potential larger drop is given by potential or the smaller drop into n to the power 2 by 3. Yes or no? Combination of the drops. So 1 drop, 2 drop, 3 drop, 4 drop, 5 drop, 6 drop, 7 drop, like that. If you are making different drops, how many drops? N drops. If you are making n drops, if you are combining this and will making the bigger drop, in that case the potential is given by this. The potential of the larger drop is potential of the small drop into n to the power 2 by 3. That's it. So potential of the larger drop. And what is charge? Charge is n into q. What is capacitance of the larger drop? N to the power 1 by 3 into c of smaller. So these are the questions. These are the direct formula that you should write. So potential is smaller. This will be n to the power 2 by 3. What is n value? So this will be 220. What is n value? 27. 27 to the power 2 by 3. Tell me how much will be getting this? 220 into 27 to 2 by 3. 9. 1980. Answer is option A. Okay. Now, two metallic spheres of radius 1 centimeter, 3 centimeter given charges minus 1 into 10 to the power minus 2 coulomb, and second is 5 into 10 to the power minus 2 coulomb respectively. If this are connected by conducting wire, the final charge on the bigger sphere will be given by. Okay. So here we have the first one is having radius of 1 centimeter and second one is having radius of 3 centimeter. The charge transfer will take place until and unless when both the bodies acquire the same potential. So this one is, let's say final charge is here Q1 dash, and here final charge is here Q2 dash. That's it. Final charge is here is Q1 dash. They are acquiring the same potential. K Q1 dash divided by R1 should be equal to K Q2 dash divided by R2. So K Q2 dash divided by R2. So K by K or K cancel. So from here I can write K Q1 dash by R1. What is R1? 1 centimeter is equals to Q2 dash by R2. What is R2? 3 centimeter. So from here we can write Q1 by 1 is equals to Q2 dash by 3 centimeter. So what is Q2 dash? 3 times of Q1. Okay, 3 times of Q1. Second is total charges, that is Q1 plus Q2 should be constant. And what is that? Q2 dash, sorry, this will be Q2 dash plus Q2 dash plus Q1 dash should be equal to total charge. What is the initial charge? Minus 1 10 to the power 2, and this is plus 5. Minus 1 into 10 to the power 2 plus 5 into 10 to the power minus 2. We got how much? 4 into 10 to the power minus 2. Solving this particular equations. So what will be getting? So solving this equation, the first one is 3 times of the second. So this I'll be writing this 4 Q1 dash is equal to this one. So what is Q1 dash? Is equal to 10 to the power minus 2. Okay, 10 to the power minus 2. And what is Q2 dash? The Q2 dash will be getting 3 into 10 to the power minus 2. So what is it asking? Put charge on the bigger sphere, that is option B. 3 into 10 to the power minus 2. Right. So this question is from electric field due to spherical shell, electric field due to dipole. So electric field due to dipole, you can note down the formula directly. Okay, so electric field due to dipole. Electric field due to dipole. So first one is, if we have, this is minus q charge and this one is plus q charge. If you are calculating at this particular point P and the distance from this is R. So this particular point P, if you want calculating, E is equals to 2kP divided by RQ. This is the axial line. On any point equatorial line, suppose if you are calculating at any point on equatorial line, so this particular point, suppose if you are calculating electric field value, so this electric field value will be given by, so this again direction will be this side, at this particular point this side, but direction of here will be this dipole moment direction, so it will be opposite of that, this dipole moment direction, so this will be opposite of this side. And what is electric field value? Kp divided by r cube. This is due to small dipole. So Kp by r cube. Okay, Kp by r cube, small dipole. The same question is asking over a magnitude of the electric field intensity distance r is very larger than L. What is L? Length of the dipole. So electric field is, you can check it over here, electric field is proportional to what? R cube. Answer will be option B. Okay, answer will be option B. Right. Electric potential they are asking, no? Electric field they are asking. Next we have electric potential. So suppose if you have minus q charge and this side if you have plus q charge, and let's say this particular point electric field is being asked over here. So because of this, if you want to calculate electric field, and this angle is theta, electric potential due to electric dipole, in that case we'll be writing this electric potential due to electric dipole is given by V. So Vp is given by K P cos theta divided by r square. Electric potential due to electric dipole is given by Kp cos theta divided by r square. Now this value will change if it is XL line. If this particular point, if they're asking, so at this particular point theta value is 0. So electric field on the electric potential on the XL line is given by Kp divided by r square. On any point on the equatorial line, when the theta is at this particular point, theta is 90 degree. So when the theta is 90 degree, electric potential Kp cos 90, this will be 0. If we are taking this side particular point, so this theta is 180 degree. Theta will be 180 degree. So this is P vector. This one is P vector. At this particular point, theta is 180 degree. Again, we'll be using the formula, that is Vp is equals to Kp cos 180 divided by r square. Different formulas at different points. We'll be getting different formulas like that. So the potential V on an XL point 2 meter distance from the center of the dipole moment is P is given dipole moment they have mentioned, that is 4 in 10 to the power minus 6. So in that case, what is the value on the XL line? At any point on the XL line, any point of the XL line, we will be using this particular formula. Let's calculate this. V on XL line, Kp by r cube, Kp divided by r square, r square. So putting the value 9 into 10 to the power 9, and what is dipole moment they have mentioned, that is 4 into 10 to the power minus 6 divided by distance. What is distance? Distance, how much? 2 meter. So this will be 2 square. So how much we got? This will get cancelled. So 9 into 10 to the power 9. So we are getting how much? So 9 into 10 to the power 3 volt. Now if we talk about this particular point on the XL line, this side will be having 9 into 10 to the power 3. On the other side will be having minus 9 into 10 to the power 3. So plus minus 9 both are possible. This statement is correct. Second is reason, V is equal to plus minus 2 by 4 pi epsilon naught. 2 is not there. In the formula you can check, K is there, this one is 2. So 2 is not there, so this region will be false. Okay, this region will be false. Distance 2 meter from the center of the dipole. From any XL point situated 2 meter from the center of the dipole. So this side, right, so this particular formula we will not be using because 2 is not there. The formula we have K into P. So this will be 4 pi epsilon naught, 1 by 4 pi epsilon naught. So 2 is not there, region is false. A is true, but R is false. Right. Next question from the again electric dipole. I think this question you can do by your own. So here short electric dipole is there, minus q, and this one is plus q, and electric dipole has a dipole moment of this much. The electric potential due to the dipole at the point of distance how much? 0.6 meter. So this distance is 0.6 meter from the center of the dipole situated on the line making an angle of how much? 60 degree. So this particular point is situated at an angle of how much? This line is 60 degree. So this particular point we have to calculate the electric potential. Again, the what is formula of electric potential? K P cos theta divided by r square. So electric potential at point P, K value is 9 into 10 to the power 9 into what is potential? That we have to calculate electric dipole moment they have given in the question. So this will be 16 into 10 to the power minus 9 into cos theta. What is theta value here? Cos theta, cos 60 divided by distance. Distance is 0.6 meter from here. That is from the center. How much distance we have to write? 0.6 ka square. That's it. Further calculation, this will give 10 to the power 9, 10 to the power minus 9 cancel over here. Cos 60 value 1 by 2. So 9 into 16, 9 into 16 into 1 by 2 divided by 0.6 square, 0.36, right? So this one is 1 and this is 0.04 and this will be 8. 8 by 0.04, answer is 200. Okay, answer will be 200. Next, we have electric dipole when it is placed in uniform electric field. So if electric dipole is placed in uniform electric field, and let's say this is the electric field direction, and this one is minus q, and this one is plus q. So when it is placed in uniform, remember this net force will be 0. So before solving this question, I am telling some of the concept that net force will be 0. Second is net torque. The torque is given by Pe sine theta in terms of the magnitude, where P is the dipole moment, E is the electric field, theta is the angle between the dipole moment and electric field. So this will be P and this will be electric field. This will be torque. So next we have third particular point that we are asking U, and what is U? Minus P dot E. And if you write this in vector form, this will be net torque is given by P cross E. Okay, so U is equals to minus P or U is equals to minus PE cos theta. Work done rotating the torque from theta 1 to theta 2. Theta 1 to work done rotating dipole from theta 1 to theta 2. So this will be writing this PE cos theta 1 minus cos theta 2. Always remember this final energy minus initial energy, cos theta 1 minus cos theta 2. Work done rotating dipole from theta 1 to theta 2. Tau net is P cross E. Next we have in this case further what are the things that we can learn from here in electric dipole. So net force will be 0 always if it is uniform electric field. Torque may be 0, may not be 0. So in this case, if they are asking SHM also, time period of SHM is going to 2 pi under root I by PE. So this is the time period of SHM of the oscillation or time period of SHM of the electric dipole. So coming back to this particular question over here, an electric dipole is placed at an angle of 30 degree with an electric field of intensity 2 into 10 to the power 5 Newton per Coulomb. Experiences a torque equals to 4 Newton per meter. Calculate the magnitude of the charge on the dipole. So here they have mentioned that torque, they have mentioned torque value, we know Pe sine theta. What is torque they have mentioned? What is value of the torque? That is 4. And what is value of dipole moment? Dipole moment we don't know. What is dipole moment? Charge into distance between the charges. So Q into D into what is E? E is the electric field, that is 2 into 10 to the power 5 into sine 30. So angle is theta. Theta is how much? 30 degree they have mentioned over here. So this will be sine 30. Right. So this 4 equals to Q. What is Q value? We don't know. Q value is what we have to write. We have to find. And what is distance between the charges? Distance dipole length is 2 centimeters. So this will be 0.02 into 2 into 10 to the power 5 into 1 by 2. So this 2 or this 2 will get cancelled. So we are getting how much? What is the value we are getting? 4 by 0.02. So 4 by 0.02 into 10 to the power minus 5 is equals to Q. On solving this 4 by 2 something 8, only one option is there, that is having 8. So this will be 8 millicoulomb. Okay, this will be 8 millicoulomb. An electric dipole of dipole moment P is aligned parallel to uniform electric field E. The energy required to rotate the dipole by 90 degree. Energy required to rotate dipole by 90 degree. What is energy required? Initially parallel. Right now minus Q and this side plus Q, initially parallel. So what is initial energy? Minus P into E. When it is rotated by 90 degree, what will be final energy? So this much will be energy minus Q and this will be plus Q. What is angle now? Angle is 90 degree. So what is final energy? Minus PE cos 90. So in this case, what is energy required? P into E. That's it. This much energy will be required in rotating the dipole. Okay. Second case, a dipole is placed in an electric field as shown in the figure. Now, what is the asking? What is it asking? Towards the right, as where the dipole, in which direction the dipole will move? In which direction dipole will move? So here this particular line is because of the electric field lines, like this we can say. So this will be dipole over here. So for example, this particular point plus Q, because of this, if we calculate this electric, so if we because of this plus Q charge is there and electric field lines. So this is one line, this is one line, this is also one line. This is non-uniform electric field lines because of the plus Q charge. And in that we are placing one dipole over here. So what actually happens? Let's see. So at this particular point, two charges are there, minus Q and plus Q and minus Q. This is near to this charge. So what will happen? This will repel it like this. This will repel it. Okay. And what about this one? This plus Q and minus Q will get attracted toward this side. But this repulsive force, let's say this one is F1 and this one is F2. F1 is the force between this plus Q and plus Q. That will be repulsive. And that is more than this. F1 is the force between this plus Q and this minus Q. And that will be attractive. So overall, repulsive force is more than attractive force. We can see, because direction of electric field line, I have assumed there is one charge over, or repulsive force is more than attractive force. So where it will move? So this will try to move in this direction. It will move in right direction towards the right. As its potential energy will decrease. And we'll check this. What is potential energy? U is equals to minus of P dot E. So U is equals to minus of P dot E. So potential energy decreases anything that we want to achieve the stability. So when it moves towards right side, so this will, it will move towards the right side and potential energy will decrease. Okay, potential energy will decrease. Right. So this concept, that is the equipotential surface. It is the locus of all the points. It is the collection of all the points which are at the same potential. That surface is what we define equipotential surface. So if this one is equipotential surface, this particular point, this particular point, this particular point, this particular point, all the points will be having same potential. This is the first definition. Second is that if you are taking any charge from one point to other point, the work done in taking the charge from 1 to 2 or 2 to 3 or 3 to 4 or come back to again, it will be 0, because work done is what? Change in potential multiplied by charge. So change in potential is 0. So delta V between any two surface will be 0. Okay, so this will be, work done will be 0. Second is equipotential surface. It can be 3D, it can be 2D as well. So angle between electric lines of this third particular point, electric field is always perpendicular to potential surface, equipotential surface, always perpendicular to equipotential surface, equipotential surface. Okay, this is always perpendicular to equipotential surface. Right, so this angle will be 90 degree. That is angle between electric field and potential will be, potential surface will be 90 degree. Second, so this particular case, the charge is taken from point A to B in this particular manner. What is initial potential? 10 volt. And what is final potential? 40 volt. So 10 volt to 40 volt here. Again, the charge is taken from A to B. Again, what is initial potential? This will be 10 volt. It is taken to 40 volt here. Again, charge we can see from here, that is 10 volt to 40 volt. And here also charge is taken from 10 volt to 40 volt. So in all of these cases, what is the same? Delta V same. And what is work done? Work done is Q multiplied by delta V. So work done is given by Q multiplied by delta V. Same charge is taken in all of these cases, no matter in which direction it is taking, no matter, it depends on what is initial point 10 volt potential and what is final point 40 volt potential. What is initial point 10 volt potential and what is final point 40 volt potential. In all of these four cases, initial point potential is 10 volt and final point potential is 40 volt. Work done will be Q into 40 minus 10. So for this 30 into Q, that is the total work done in all of the cases. Answer is which option here? The work done is same in all the four cases. Remember, this work done is given by Q multiplied by delta V, and delta V is the initial potential minus initial potential and final potential के बीच का difference, right? So this question, that is the potential in a region is expressed as V equals to x y z, that is 6xy minus y plus 2yz. The electric field in Newton per coulomb at point 1, 1, 0. Relation between electric field and potential. Remember this, whenever electric field and potential is given, so we want to write that is Ex equals to minus del V by del x, and what is Ey? Minus del V by del z, and what is Ez? Ez is minus del V by, this is del V by del y and this is del V by del z. So here we define that electric potential is given, they are asking electric field. So E is equals to minus of del dV by dr. So differentiate with respect to this. All of you know partial differentiation. So partial differentiation we have to do with respect to x. Other term will be constant. So here we will getting 6y plus 0 plus 0. So this will be minus. So because, and this side Ey. What is Ey? You do the partial differentiation. When you are doing partial differentiation, this will be again minus 6x plus 1. And this particular term plus 2z. Again, this partial differentiation if we do here. So when we do with respect to xz, so this will be constant now. So this will also be constant. So this will be 0 and this will also be 0 plus this one is 2yz is there. So this will be 2y, right? And that 2 minus 2y, because minus is sitting outside. So this will be minus 2y. So this side total that we are getting Ex value, putting this value 1 comma 1 comma 0. So what is Ex? The Ex value will be given by minus of 6 into 1, right? Next. And what is Ey? The Ey, putting this x equals to 1, y equals to 1, z equals to 0. So this will be 6 into 1 minus plus 1 plus 2 into 1. So we got minus 6 plus 2. Minus 6 plus 2 we got 4. Then last is Ez. And what is Ez? The Ez will be given by this minus 2 into 1. So we are getting the answer. What is the answer we are getting? Electric field is given by minus 6 I cap plus 4 j cap. We are getting plus 4. Let's check it. Somewhere if I have done the mistake over here. This side, this is 2 plus 1 minus 6. 2 plus 1 minus 6. That is minus 3, right? So we are getting here minus 3, not the plus 4. So we are getting this minus 3 j cap and this is minus 2 k cap. Which option? So if I take minus common, 6 I cap plus minus 3 j cap plus 2 k cap we are getting. So let's check this. Somewhere we are doing the mistake over here. So this z value is 0 now. Wait, this z value is 0. Wait, this z value is 0. So this will be 0 because z value here is 0. 1 comma 1 comma 0. So this will be 0. So this is minus 6 plus 1. This is minus 5. And this, so minus 6 minus 5 and minus 2. Minus 5 and minus 2. Answer is option D. Clear? So remaining some questions from the capacitance. Let's see 1 or 2 questions we can see, and we can discuss this capacitor some later on because we are lagging behind the time. So here the capacitance of capacitor which charge Q and potential difference V. The capacitance depends on Q divided by V. Remember this. Capacitance will depend on Q divided by V, where Q is the charge, V is the potential difference. But capacitance does not depend on Q and does not depend on V. Mathematically it depends on Q and V, but not physically. Because once the capacitor is manufactured, its capacitance value is constant. On increasing the potential, Q will increase. On increasing the charge, V will also increase. So here it depends on geometry. Okay, it depends on geometry. A 13 microfarad picofarad capacitor is connected to 50 volt battery. The electrostatic energy is stored in nanojoule. So if the capacitor is connected and battery is also there, so in this case what is 60 volt and this one is 12 picofarad. So in this case I'll be writing this. So what is the energy stored? Half CV square. Energy stored is half CV square, half CV square, or Q square by 2C, or QV by 2. Depending on this, questions will be using different formulas. So U is equals to half into 12 into 10 ki power minus 6 into what is potential difference? Potential difference is 50 into square. So we'll be getting this. This one is 6, 50 square, 25 into this 150 we are getting. So 150 into 10 ki power minus 4. 150 10 ki power minus 4 in nanojoule they're asking, right? So in nanojoule if they're asking, so this will be, so this is 10 ki power minus 6, capacitance value is 12 picofarad now, sorry. So this will 12 into 10 ki power minus 12, right? 10 ki power minus 12 into 50 square. So into 50 square. So this side 2500 into 6 into 10 ki power minus 12. So this will be 150 into 10 ki power 3 into 10 ki power minus 12. We are getting 150 into 10 ki power minus 9. We are getting this in terms of the joule. Answer is 150. Okay. The plates of the capacitance value is given by C is equals to A epsilon naught divided by D. Okay. The plates of the parallel plate capacitor connected to the battery are moved close to each other. So plates are moved close to each other. Okay, fine. It is connected to the battery. So what will happen? Let's see. So when this D is the distance between these two plates, and what is A here? Area of these plates. Area of these plates, whatever the area we have, this area of the plates. So when they are moving close to each other, D is decreasing. So what happens? D decreases. So from the given formula, D decreases, capacitance value will increase. As the capacitance value will increase, but potential value will remain same. Its capacitance increases, yes, C increases. Energy, and what is energy? Half C V square. I told you, as long as the battery is connected, this will be having same potential. Potential difference will not change as long the battery is connected. So U is equals to half CV square. C increases, so U also increases. Energy stored in it increases. So this one is wrong. Charge, what is charge? Charge Q is equals to C into V. V is constant, but C increases, so Q also increases. A is also correct. The ratio of the charge to its potential difference remains same? No. C is equals to Q by V, right? So capacitance increases, so this is wrong. This one is also wrong. The product of a charge and voltage increases. What is that? Q into V. Yes, this also increases. So this answer is A, C, and E. Answer is option B. Right, so there are some more questions. We might discuss the capacitor in little bit detail over any other videos over here. So tomorrow's chapter, that we'll be discussing current electricity. I would say this is the highest weighted chapter for NEET. Especially one chapter is this and second is optics. So don't miss this particular lecture tomorrow. We'll be discussing what is the Ohm's law, what is the Kirchhoff's law, what is the cell's EMF internal resistance, electrical energy and power, and electrical measuring instruments. So these are the topics that we'll be covering in the next chapters. That is current electricity. The weighted chapter for the NEET, maybe 6 to 7% questions we can expect from this. 6 to 7% of the questions, total questions. So this is for the today's class we have. Some part we tried to cover some major portion which has been asked repeatedly, and we solved some of the questions that is in the previous year. We discussed the topics, and you keep practicing whatever the practice you are doing, keep practicing, and we'll meet again on the Monday with this chapter.